Here we have a rectangle field, fenced around the outside and divided into two pens by a fence. We're going to symbolize the width of this rectangle with the letter X and the length of the rectangle with L. We're first asked, if we have 600 feet of fencing to use, write an equation for the length in terms of X. When you see the word fencing in any word problem, the first thing we need to think of is perimeter. So let's begin by writing a perimeter equation. The perimeter of this shape is the length of all the sides added together. We can see that we have two sides labeled L and three sides labeled X. For this reason, we can say the perimeter is 2L plus 3X. We can also say, because we know we have 600 feet of fencing, that this must add to make 600. Then we are asked to write an equation for the length, so we must solve for L. To solve for L, we're going to take the 3x and move it to the right side. If we do so, we'll now have 2L equals 600 minus 3x. Then to get L by itself, we can divide all terms by 2. Therefore, we'll say L is equal to 600 over 2, which is 300, minus 3 halves x. This will be our equation for L. This also means anywhere L appears elsewhere in the problem, we can replace it with 300 minus 3 halves x. For part B, we are asked to find the domain of x. We must say, since we're using a real-world shape, that x must be greater than 0 because there's no such thing as a negative distance in these sorts of problems. However, the length that we wrote, the 300 minus 3 halves x, must also be greater than 0. We'll draw a number line now. We know that x must be greater than 0, and we'll place an open circle on 0. We'll also put a green arrow to show that we must go right from 0. But now we have to solve our other inequality, 300 minus 3 halves x greater than 0. To get x by itself now, we will subtract 300 from both sides. If we do our subtraction, we'll get negative 3 halves x is greater than negative 300. Now to get x by itself, we'll multiply by the reciprocal of the fraction next to x. The reciprocal of negative 3 halves is negative 2/3. If we make that multiplication, on the left we'll have only x remaining. On the right, if we take negative 300 times negative 2/3, we'll end up with positive 200. Since we multiplied by a negative, we must flip the inequality sign, and so x must be less than 200. So we'll put an open circle on 200, and then to show that we are less, we draw a green arrow to the left of that. The solution set will be anything between 0 and 200. So our domain will be 0, 200 with parentheses. Part C asks, using your length, write an equation for the area of the pen. To find area of this rectangle, we'll take length times width. The length is L, and the width is x. But now we may replace the L with the 300 minus 3 halves x we came up with earlier. We can now say area is equal to the binomial 300 minus 3 halves x times x. We'll multiply both terms of that binomial times x. When we multiply, we'll take x times 300 for 300x, and x times negative 3 halves x, which gives us negative 3 halves x squared. Therefore, our area is negative 3 halves x squared plus 300x. Now that we have an equation for area, we may find an x value that maximizes the area of the pen, and find the maximum area that goes with it. Remember, when we see the word maximize, we want to think about the vertex. To find the vertex, we will say x is equal to negative b over 2a. In our area equation, our a value is the number next to x squared, and that's negative 3 halves. And we can say negative 1.5 if we wish. Our b will be 300. We place those numbers into the formula, and we'll have negative 300 for our b, divided by 2 times negative 1.5. 2 times negative 1.5 gives us negative 3. So we'll have negative 300 over negative 3, and x will equal 100. This will be the width of our pen. You may sometimes be asked to find the dimensions of the pen, in which case you must give the length and the width. Therefore, if I had asked you for dimensions instead, you would not only give the width, you'd also have to find the length. However, since we know that x must be 100, we can say the length is 300 minus 3 halves times x. However, we're replacing this x in our length equation with the number 100. If we take 3 halves times 100, that would give us 150, and 300 minus 150 is 150. Therefore, if your question ever says dimensions, give the width as 100 and the length as 150. We can also find the maximum area. This is still based on the fact that x is 100. We know area is equal to negative 3 halves x squared plus 300x. But we'll let all of these x's become 100. Therefore, our area is now negative 3 halves times 100 squared plus 300 times 100. We'll go to a calculator and do the math. We'll end up with 15,000. Therefore, we can say our width is 100 feet, our length is 150 feet, and our area is 15,000 square feet. These will be the maximum dimensions for this pen.